Okay, so this is the questions and answers of the chapter direct current. A conductor of a cross-sectional area which decreases with a distance x is shown. When a constant current flows through the conductor, which graph shows the variation of current density with the distance x? You know that the J equal to I over A. When I is a constant, and then when A decreases, you know J will increase. So this is the only possible graph. A copper wire is carrying a current. The copper wire is stretched while the current is kept constant. What happens to the magnitude of the current density? Okay, while the copper wire is stretched, you know that the cross-sectional area will decrease. When area decreases, J will increase. A potential difference of 2 volt is applied across a wire of resistance 8.2 ohm. Find the number of electrons that flows through a cross-sectional area in the wire in 30 seconds. V equal to IR. By using the Ohm's law, you can get the value for I. And then you know that the total amount of charge is equal to N times E, which is also equal to I times T. Okay? Then you substitute for the value, then you can get how many numbers of electrons that flow through the wire. Remember, I equal to dq dt. So when I is constant, Q equal to I times T. But however, if the function for the current is a very weird function, for example, let me give you a sinusoidal function, then your Q would be a sinusoidal function as well. You really need the value of the time so that you can solve for Q. However, in this question, we know that I is just a number, and that's why we can straight away multiply it with time to get the total amount of charge. A wire has a diameter of 0.52 mm and a length of 40 cm. When a potential difference of 1.2 volt is applied across both the ends, the current that flows is 2.5 ampere. Please find the resistivity. You are given V and I. Of course, we have to find the R first. Then you use R equal to rho L over A to find the resistivity. If the wire is cut into halves, what happens to the resistance and resistivity? First of all, we take a look at the resistivity first. Resistivity only depends on types of the material and also temperature. So even if you cut the wire into halves, resistivity will not change. And then R equal to rho L over A. So you know that R is directly proportional to L. If L decreases by half, then R will decrease by half. Just now R is this value. Right now R is this value. Just now rho is this value. Since resistivity does not change, then rho is still this value. Bulb P and bulb Q are rated at 60 watt, 240 volt, and 100 watt, 240 volt respectively. If the filaments of both bulbs are made of the same material and have the same length, the filament Q has, you know that power equal to VI equal to I square R equal to V square over R. And then you are given P and also V. Therefore, you can find the resistance now. You know that the resistance of P is greater than resistance of Q. Okay, so this is wrong. And then in the question, it states that we use the same material. Therefore, if you are using the same material, then of course the resistivity is still the same, because resistivity only depends on type of material and also temperature. Okay, when ρ and L is constant, you know that R is inversely proportional to A. Okay, and therefore when the resistance of P is greater than resistance of Q, therefore the area of Q is larger than area of P. So area of Q is larger, has a larger cross-sectional area than P. Because they are using the same material, and therefore the resistivity and conductivity are the same. The element of a cutter is made from a Necron ribbon of length 5 meter, width 1 mm and thickness 0.05 mm. When a current of 2 ampere flows in the element, the dissipated power is 500 watt. Find the resistivity of the Necron. Okay, you know that P equal to VI equal to I square R equal to V square over R. Then you use this formula, okay, because you are given P and I only. Therefore, you can get the resistance, and then R equal to rho L over A. Then you can find the resistivity. A conductor of cross-sectional area 5 times 10 power negative 6 meter square carries a current of 6 ampere. The conductivity of the conductor at room temperature is 3.13 times 10 power 7 per ohm per meter. Find the electric field strength inside the conductor. Okay, you know that electric field strength is equal to the potential difference across a length of conductor, and then V equal to IR because of Ohm's law, and then R equal to rho L over A. Therefore, you know that the reciprocal of resistivity is equal to conductivity. So you know that E equal to I over sigma A. Okay? Or you can use J equal to sigma E. Okay? And then J equal to I over A. By using this formula, you also get E equal to I over sigma A. State the main factor that causes the drift velocity of the free electrons, which is the electric field inside the conductor. The greater the electric field inside the conductor, the greater the drift velocity of the free electrons. State two main factors that determine the resistivity. You know that resistivity only depends on type of material and also temperature. State three factors determining the resistance of a conductor. R equal to rho L over A. So the factors are resistivity, length, and also area of the conductor. Potential difference V is supplied across a uniform wire of length L and cross-sectional area A. The number of free electrons per unit volume is N, and the resistivity of the wire is ρ. If E is the charge of an electron, the drift velocity of free electrons is, okay, from V equal to IR, and then I equal to NAVE, and then R equal to rho L over A. You can finally get the expression for the drift velocity. When an electric field is applied to a metal conductor, the free electrons drift with a velocity v. If the mean time between collisions is t, the mass of electron is m, the charge of electron is E, and the electric field strength is capital E, the correct expression for V is, okay, you know that inside the conductor, the electric field will exert an electric force on the free electrons. So M equal to EE equal to mv over t. Okay, F equal to ma is the Newton's second law. F equal to EE comes from the definition of the electric field strength. Okay, therefore you know that V equal to this expression. Copper has a resistivity of 1.69 times 10 power negative 8 ohm meter and a free electron density of 8.47 times 10 power 28 per meter cube. Estimate the mean time between the collisions of free electrons and positive ions in the copper. Okay, conductivity equal to N squared tau over M, and then conductivity equal to the reciprocal of resistivity. Okay, by using this you can get the mean free time. Okay. A potential difference of 2 volts is applied across a metal wire of length 24 cm and cross-sectional area of 5.03 times 10 power negative 3 cm squared. A current of 1.5 ampere is produced. Please determine the electric conductivity of the wire. J equal to sigma E, and then E equal to V over D, J equal to I over A. And then from this expression, you can find the conductivity. Please remember that the conductivity has a unit of per ohm per meter. And then the unit of the resistivity is equal to ohm meter. The mean free time between collisions of free electrons with atoms is 1.78 times 10 power negative 15 seconds. Determine the number of free electrons per unit volume. Conductivity equal to NE squared T over M. Then you substitute everything inside. Then you can get N. Calculate the drift velocity for the free electrons. Compare this velocity with typical speed of free electrons in a solid, which is in the order of 10 to the power of 6 meter per second. From I equal to NAVE, you can finally get the value for the drift velocity. The drift velocity is the average speed of free electrons from low potential to high potential due to acceleration by electric field and collisions with atoms. Okay, I need to remind you that the drift velocity is very small compared to the typical speed. Alright, okay, and then the typical speed of this big magnitude is the random speed of the electrons due to the temperature in all directions. That means that this is contributed by the thermal energy. A copper wire has length 1.75 km and diameter 2.35 mm. A potential difference of 115 volt is applied across the wire and current flows through the wire for 150 seconds. Resistivity of copper is 1.7 times 10 power negative 8 ohm meter and electron density is 8.49 times 10 power 28 per meter cube. Determine the current in the copper wire. Okay, from R equal to rho L over A, then you can get the value for R. And then from V equal to IR, you can get the value of I. Calculate the drift velocity in the copper wire. I equal to NAVE. Okay, then by using this, you can find the drift velocity. Determine the total number of electrons which passes through a point in the copper wire. Okay, the total charge Q is equal to NE, which is equal to IT. Okay, then you can get the total number of electrons. Copper has a molar mass of 63.5 times 10 power negative 3 kg and a density of 8,900 kg per meter cube. Assuming that each copper atom contributes one free electron, calculate the drift velocity of the electrons in the copper wire of radius 1 mm carrying a current of 0.15 ampere. Okay, you know that free electron density is equal to rho Na over m, where the rho here is the density. Alright, the rho here is the density, not the resistivity here. Okay, and then you substitute everything inside, then you can get the N. And then you substitute the value of N inside the I equal to NAVE, and then finally you can get the value of the drift velocity. Assume each copper atom contributes one free electron. Given the density of copper is 8940 kg per meter cube and molar mass of copper is 0.0635 kg per mole. Please calculate the number of free electrons in the copper cube, which is of side 10 cm. Okay, and then free electron density is this, N equal to rho Na over m. Rho is the density, Na is the Avogadro's number, and then m is the molar mass. Then after finding the free electron density, you multiply it with the volume. Then you can find total number of free electrons. The drift velocity of electrons in an aluminum wire is 1.66 times 10 power negative 4 meter per second. The cross-sectional area of the wire is 5 times 10 power negative 6 meter squared. Assuming that the aluminum wire is supplied with one free electron by each aluminum atom, what is the current in the wire? Okay, you are given the density and then the molar mass. So you know that you will use the formula N equal to rho Na over M. Then you use I equal to NAVE to find the current. The drift velocity of free electrons in a conductor is very small, but a bulb can be lit up almost immediately after the switch is closed. Which statement explains this situation? Because all the drift electrons will experience the force simultaneously, and therefore all the free electrons will drift simultaneously. Drift velocity of free electrons in a metal conductor is the mean or the average velocity of the free electrons in the conductor, which is due to the electric field and also the collisions with the lattice atoms. Which metal conductor and semiconductor correspond correctly to their characteristic at high temperature? Okay, when it's at high temperature, you know that for the metal conductor, the conductivity will decrease and then the conductivity of semiconductor will increase. When the conductivity decreases, the resistivity increases. When the conductivity increases, the resistivity decreases. For a metal conductor, you know that the number of charge carriers is almost a constant. And then for a semiconductor, the number of charge carriers increases at high temperature. Because you know that for the semiconductor, you have a very small energy band gap between the conduction band and also the valence band. So when it comes to very high temperature, then the electrons here can gain some thermal energy to be promoted to this band, so that the electrons now become free electrons to conduct electricity in the semiconductor. However, inside the conductor, you know that the conduction band and also the valence band actually overlaps. That means that the carriers inside the conductor is almost a constant. That means that the electrons don't even have to gain some energy to be promoted into the conduction band. They are already inside the conduction band. So you know that the charge carriers inside the conductor is a constant, no matter how the temperature rises. Okay, the mean free time between collisions decreases. Yes, because when the metal conductor gets very hot, the lattice vibration will get bigger, so that the mean free time between collisions decreases. And then the same thing happens in the semiconductor, so that the mean time between collisions also decreases. Okay, but then you have to remember that although T decreases, the N increases by a greater value, so that you know that the effect of the increase in N is definitely greater than the decrease in T, so that the rho will decrease. Okay, and then in this situation, N is a constant, and then when T decreases, rho will increase. Okay, so in both cases, the T will still decrease. The increase in the electrical resistivity of a metallic conductor when its temperature is increased is due to the increase in the amplitude of the lattice vibration. Okay? The magnitude of the drift velocity of the charge carriers in a semiconductor is dependent on the following, except, okay, you know that I equal to NAVE. So the drift velocity can depend on I, can depend on N, can depend on A, and also depend on E. However, for holes, which is the positive charge carriers, and then for the free electrons, which is the negatively charged carriers, the magnitude of their charge is the same. They are only of opposite signs, but then they have the same magnitude. So you know that the magnitude actually does not depend on the type of charge because both of them has the same magnitude. Which graph shows the variation of resistivity rho with temperature T of a superconductor? Okay, for a superconductor, you know that when it comes to a certain temperature, the resistivity drops to 0. That means that below the critical temperature, okay, we call this critical temperature, which is Tc. C means critical, T is temperature, okay. When it's below the critical temperature, the resistivity straight away drops to 0. But then when the temperature rises above the critical temperature, the resistivity will increase with the increase in temperature. Okay? The variation of the resistivity of a material with temperature is shown. Resistivity will decrease by the increase in temperature. The most likely material is a semiconductor, okay? Because when the temperature increases, the number of charge carriers increases, so that the conductivity increases and then the resistivity decreases. Which statement about the conduction of electricity is not true? Conductivity of metals increases at a higher temperature because the free electrons move faster. This is wrong because conductivity of metals decreases at a higher temperature because the lattice vibration gets larger and larger, so that the mean free time of the free electrons decreases. The conduction of electricity in metal is due to the drifting of the free electrons.